China just pulled off something big and barely anyone's talking about it. Their new crew spacecraft, Mengzhou, just aced a critical emergency escape test, proving it can save astronauts before a rocket even lifts off. This isn't just about safety, it's a massive leap towards sending humans to the moon by 2030. In this video, we'll break down how the test worked, what makes Mengzhou so advanced, and why this changes the future of lunar exploration. The Abort test on June 17, 2025, at Jiuquan Satellite Launch Center. On June 17, 2025, at Jiuquan Satellite Launch Center in China's Gobi Desert, engineers successfully executed a dramatic scenario, a launch pad abort simulation using the Mengzhou crew spacecraft. These next steps will further prove the reliability of the system under real-world launch conditions. For now, this successful pad abort test sends a strong signal: Mengzhou's integrated safety architecture is operational, marking a bold step toward its future role in crewed missions to low Earth orbit and beyond. It's built around modern design philosophies that prioritize modularity, reusability, and comprehensive safety. The spacecraft will operate in two variants: a low Earth orbit LEO version capable of carrying up to 7 crew members or about 500 kilograms of cargo, and a lunar orbiter variant designed for 3 astronauts, who will transfer into a separate lander for descent to the moon. At exactly 12:30 p.m. local time, ground teams triggered the spacecraft's solid fuel escape tower without any actual rocket attached. Its success sets the stage for it to serve as China's workhorse vehicle, both for ongoing space station supply missions and future crewed lunar expeditions. Unlike older spacecraft models, which relied on rockets to provide separation in an emergency, Mengzhou's system self-manages escape, parachute deployment, and landing. The next step in this strategy is a full-scale in-flight abort test planned later this year. That test will push the escape system to its limits, during peak aerodynamic pressure shortly after launch. Every system element from launch pad readiness to in-orbit operations must be fully operational before astronauts can take off. With NASA's Artemis program facing budget constraints and timeline uncertainties, China's systematic, step-by-step testing offers a clear roadmap. Mengzhou's pad abort test is not just technical validation, it has a statement that China is methodically building toward a lunar milestone that could arrive by 2030. It doesn't just provide an alternative, it represents a parallel pathway to sustainable lunar operations. And China plans to follow a staged, cumulative approach: first crewed orbital missions, then docking tests with lunar hardware, then crewed lunar orbit flights, and finally crewed lunar landings. With Mengzhou's escape system operating flawlessly from ignition to landing, the foundation is in place for future in-flight tests and eventual crewed lunar missions. The spacecraft's advanced integration, alongside powerful new rockets and a dedicated lunar lander, underscores a comprehensive roadmap to the moon. If everything proceeds as planned, China could achieve its first crewed lunar orbit and landing by 2030. Thanks for watching. If you enjoyed this deep dive, please like, subscribe, and share your thoughts about China's bold leap into lunar exploration. By proving the system works during real mission conditions, engineers will gain confidence that Mengzhou is ready for crewed orbital and lunar launches. When the crew triggers an abort, the escape tower fires, separates cleanly, and the spacecraft switches to parachute sole within a few seconds. Designed specifically to deploy both the Mengzhou crew capsule and a purpose-built lunar lander, this rocket will operate from the coastal Wenchang Space Launch Center on Hainan Island. It's an integrated architecture: capsule, booster, and lunar lander, all built to function together in crewed missions that include docking, orbit insertion, and lunar descent. Airbags cushion the touchdown, even when descending at low altitude. This unified design minimizes system complexity and enhances reliability. Within seconds, the capsule rocketed upward to a preset altitude. That alone underscores the significance of this achievement, but there's more. Unlike previous systems, Mengzhou consolidates escape and rescue into a single unified system. That test verified heat shield performance and structural resilience at reentry speeds. Each step had to occur flawlessly to prevent cascading failures. Engineers had to account for various unpredictable factors such as wind shear, capsule spin, and parachute timing to create a robust, resilient system. The June 2025 pad abort test builds on that knowledge, specifically validating emergency safety systems under realistic conditions. Where older designs depended on the rocket for separation and escape, Mengzhou's system handles everything itself. This integration streamlines operations and reduces points of failure, giving mission planners more confidence when preparing for crewed flights. Once aloft, it's separated from the escape tower, deployed parachutes, and used airbags to cushion the landing. Touching down safely about 2 minutes after ignition, China's Human Spaceflight Agency officially declared the experiment a complete success. This test represents a critical safety milestone. It is designed to replicate a high-stakes emergency where something goes wrong on the launch pad before the main rocket engines fire. The system had to react instantly, control trajectory precisely, and ensure parachutes deployed under low-altitude conditions all in a very narrow time window. Success in this environment proves that the spacecraft can reliably protect crew members in the most dangerous moments. This marks China's first pad abort test in 27 years, since the Shenzhou spacecraft's emergency test in 1998. By completing this test flawlessly, China moves closer to conducting more advanced abort simulations, especially in flight tests during peak aerodynamic stress. The Mengzhou spacecraft design, variants, and integrated safety system, Mengzhou, which translates to Dream Vessel, is China's versatile next-generation crew capsule engineered for missions to both low Earth orbit and lunar orbit. A major innovation of Mengzhou lies in its integrated abort and rescue system. In May 2020, a test version of Mengzhou launched aboard a Long March 5B rocket and completed a high-speed re-entry after TWO days in orbit. From a technical standpoint, integrating all rescue functions into the vehicle itself required precise coordination, timing of escape, ignition, structural separation, parachute deployment, and landing stabilization. With its modular capability, reusable design, and advanced safety features, Mengzhou stands out in global crewed spacecraft. 3. Path to the Moon missions, rockets, and what's next approximately equals to 160 words. China's successful pad abort test removes a major technical barrier on its path to landing astronauts on the Moon by 2030. This testing sequence aligns with the parallel development of China's Long March 10 rocket, a heavy-lift launcher featuring 3 core stages powered by new YF-10A engines. Lander development continues in tandem, along with upgrades to ground facilities and mission control capabilities. Globally, these developments position China as a major contender in the new era of crewed lunar exploration. For audiences monitoring space exploration, China's strategy offers key takeaways: the importance of incremental validation, integrated mission architectures, and relentless focus on safety. China's pad abort test on June 17, 2025, marks a turning point in its lunar ambitions.